In this lesson, we'll be doing an introduction to hyperbolic function, also known as the hyperbola. The hyperbola. Okay. So, the basic form of hyperbola that has not been transformed or shifted is given in the form y is equal to a over x plus or minus q. Now, x and y stands for the axis, or rather the intercepts. Now, there's something important about the value of a. Okay? If a is positive, or if a is more than 0, our graph lies in the first and the third quadrant. So the way in which the quadrants work, you start from this one. It's 1, 2, 3, 4. Okay? So what we say here is that if a is positive, therefore our graph will lie in this quadrant as well as this quadrant. That's quadrant 1 and quadrant 3. I hope it is clear. And again, we can say that if a is negative, or if a is less than 0, our graph lies in the second as well as the fourth quadrant. Okay? And the quadrants are separated by an asymptote. Okay? So, let's talk about the value of q. What is q? Q is what we call an asymptote. Q is an asymptote. So, an asymptote by definition is a line that a graph approaches but never touches. This means that the values of y are not defined on the asymptote. Okay? They don't exist. They don't touch the asymptote. We say it's a line that the graph approaches, come near and near to, but will never touch it. And something that we must note here is that we have x on the denominator. And we know that division by 0 is not allowed in maths or in mathematics. So we can say that therefore x must not be equal to 0 as long as we have x only below. So x must not be equal to 0. So let's have an example of how we can draw a graph. Suppose we are given the graph y is equal to 4 over x plus, did I just say q, plus 2. They say sketch the graph, give the domain and the range. So we're going to talk about the domain and the range soon. So that's domain and range. So first of all, we must check the basic form is given as y is equal to a over x and plus q. Now, here is a. What is the value of a in this case? That's 4. Is 4 positive or is it negative? Well, it's positive. This means my graph must be in this quadrant as well as this quadrant. Okay? So, we're going to draw it. We're going to look for the y-intercept, but it doesn't have the y-intercept. Okay, why do I say so? We said for y-intercept, let x be equal to 0. So, did we say it's allowed for x to be 0? No. As long as we have x alone in the denominator, we don't have the y-intercept. But we do have the x-intercepts. So, we can say that for x-intercept, let y be equal to 0. And we're going to cross multiply. We're going to say that 0 is equal to 4 over x plus 2. We're going to take the 2 to the left side and will become negative. Then negative 2 is equal to 4 over x. We cross multiply and then negative 2x is equal to 4. And then at the end, our x is equal to negative 2. So what are the coordinates? x is negative 2 when y is 0. Okay, note that. So what we're going to do here is that we have the x-intercept here, and we have the q, the asymptote. Q is equal to positive 2 is given. So we're going to go ahead and draw our graph. We must first draw the system of axes. Make sure you draw this using a ruler. And here we're going to have 1, 2, 3. Note that mine are not to scale. And here we'll have 1, 2, 3, 4. And this side is minus 1, minus 2, minus 3. And this side is minus 1, minus 2, minus 3. So we're going to plot the coordinates which we have calculated. Okay, so we had minus 2 and 0, so that's going to be here. And we have the line y is equal to positive 2. Whenever you see a line written y is equal to, that line goes like this and touches the y value at 2. That's what we call the asymptote, and you must label it as y is equal to 2. This means that your graph will never touch this. And look at this. This is the y-axis. This here is the y-axis. This means that the values here represent the values of x and y. The values of x, okay. So here it's 0. The origin is 0. And the values of x are 0 as long as they are on this line. The values of x are 0. So what we're going to do is that x must not be equal to 0. This means that your graph must not touch this line. I hope it is clear. Your graph must not touch this line. So your graph will go like this. Will approach the asymptotes but will never touch them. And this is the first arm. The second arm, you are going to draw it in the first quadrant, making sure that it never touches the line of y is equal to 2, and it doesn't touch the line of x is equal to 0. Only if your hyperbola is given in the form y is equal to a over x plus q. That's when your graph will never touch the y-axis. Never. Okay? So this is how we can do it. So from the graph, I need us to come with the domain as well as the range. So what do we mean by domain? We say that domain are all the possible x values that are found on the graph. Okay, so let's start with the domain. Domain are all the possible x values that the graph has. So all the values of x are defined on the graph. So we say x is an element of real numbers, except one place where we say x must not be equal to 0. Those are the domain. Okay, the domain, we focus on the x. We're talking about the possible x values that a graph might have. And then the range, the possible y values that the graph might have. Y is an element of real numbers. This means all the values of y are possible on the graph, but y must not be equal to the asymptote, which is 2. Okay, we said somewhere that y is not equal to q. Okay, so there it is. We said that y is not equal to q, and q in this case is 2. There it is 2. So you must know from today that when we're talking about the domain, we're talking about the possible x values that the graph might have. And the range, we're talking about the possible y values that a graph might have. And these are the domain and the ranges of a hyperbola only. Do not use this in a parabolic situation. No, these are only applicable to hyperbolic functions. I hope it is clear. And don't forget that in order to know how your graph will be, either in the first and third or second and fourth, you must first know what is the value of a. If the value of a is positive, it means it's going to be in the first and the third quadrant. But if it's negative, it will be in the second and the fourth quadrant. And as long as our hyperbola is given in this form, okay, as long as it's given in this form, x will never be 0, because if we say 4 divided by 0, you will get mass error. That's why we say that x is not equal to 0 when we are talking about the domain. All the values of x are possible for this expression, but not 0. I hope you understand this. Yes. So make sure you are able to understand this. This is grade 10 scope, grade 10 syllabus. So I just decided to recap it before I go to the actual stuff here. So make sure you understand how to deal with the basic form of a hyperbolic function. Suppose that it comes in this form, then you must be able to handle it. You must know that as long as it's in this form, x will never be 0 and y will never be q. Thank you for watching.